Hey everybody, Monty, Miller, Pi Day. I know, yesterday was 3/14, March 14th, but it's Monday, Tuesday, it's the 15th and 16th, and it wouldn't be a true geometry class without celebrating pi. Do you know where pi comes from? Maybe, maybe not? Okay, well, we got a whole bunch of vocabulary for Pi Day, right? Circumference, diameter, radius, and this universal number 3.1415. Well, without further ado, let's start out with a couple of songs about Pi Day, all right? Okay, so now in class you're going to get to hear that whole song, and then we have another one that we're going to play also, in case that wasn't enough. What's this pi thing you're making such a big deal about, Monty? So let's see if we can sync this up. I had a little trouble on the first one, so commercials, what the heck.
And now, ASAP Science presents
Alright, so here we go.
Digits of pi. 3.14159, this is pi, followed by 2653589, circumference over diameter 79, then 323, OMG, can't you see? 8462643, and now we're on the screen. 38 and 32, now we're blue, oh who knew? 7,950, and then a 2. 88 and 41, it's so much fun, now we're on 9716939 and 3751. Halfway done. 458, now don't be late. 209, where's the Y? 74, it's on the 4, then 94459. 230, we gotta go. 78, we can't wait. 1640628, we're almost near the end. Keep going. 62, we're getting through. Oh wait, 9 out of 10. 862, 804, there's only a few more. 82, then 53. 42, 11, 7, oh and 67. We're done. Was that right? Learn a random digit so that you can write to your friends. Thank you guys for.
Alright, give you a little flavor for pi, a little pi song action going on there. Okay, now let's get started with our Monday, Tuesday pi activity. Okay, first thing we got to do is make sure that we can calculate pi. Alright, so Mr. Miller's going to hand out this sheet right here, and it's front to back, okay, and it's got this, what's called a unit circle. What the heck is a unit circle, Monty? So, grab these sheets, and then Mr. Miller and I were looking around seeing if we could find some extra tools in the classroom. So, Mr. Miller might be able to hand out some tools. Okay, do we know what this is called? Protractor, compass, measuring device, right? Okay, so we got some protractors. Hopefully you get one of those. We might have some extra rulers because once we give them out, we don't want them back. Keep them. Serious, okay? So, you all got a sheet of paper. If you're doing this from home because you're absent, draw a circle on a sheet of paper and then just kind of copy what we do. Here we go. Activity number 1, okay? First thing we want to do is we want to get rid of that line, pi. Turns out pi is a relationship between the circumference and the diameter. Circumference. What is circumference? You guys know circumference? You remember him? Circumference? Oh, come on, everybody. It's Pi Day. Let's smile. Can't eat pie today. All right. So, circumference is the distance around. Okay? Now, if you remember back a while, we talked about in math positive and negative. Counterclockwise is positive. So, draw a circle around and go counterclockwise. That's the circumference, okay? Circumference. Now, it might be hard in the classroom because we don't have any string and all the different stuff to measure the distance around the circle, okay? The distance around the circle that you have in front of you is 13 inches. That was the goal, okay? Now, take your tools and measure across, okay? Now, hopefully, you'll either have a ruler or the protractor, and the distance across our goal was 4 1/8. Okay? All right. So the diameter, 4 1/8. Now, if you want, you grab a calculator, and 4 1/8 turns out to be, go ahead and divide it out. 1 divided by 8. 1 divided by 8 equals 0.125. For those of you that don't like fractions, 4.125. Okay? Circumference. The circumference. Oh, radius. Does anybody know what the radius is? Ding, 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 ding. Half a diameter. Half the diameter. So, 2 1/16. Or half of 4.125. All right, 4.125 divided by 20625. Okay, 20625. Okay. All right. Now, circumference, if you can measure it, use your measurement. The idea was we were trying to get a 13-inch string to go around it, okay? And in a perfect world, you know, we'd have some sort of a ribbon or a string or some wire or something so we could bend it around and then straighten it out and measure it, okay? So now, circumference divided by diameter, 13 divided by 4.125. And you heard the song. It's going to be 3 point something, isn't it? So let's do it. 13 divided by 4.125. Ding, 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 ding. 315. Pretty close. Okay. 3.15. Let's do a couple decimals. 1515. All right. 1515. And if you noticed over here, 3.14159. We're not too far off. Not too far. That was kind of fun. All right. So, pi. And then, why don't you practice drawing the pi symbol? A little squiggle with 2 legs. Pi. Do you know where pi is on your calculator? Get your Webbit out. And pi is right there. Pi is second caret key. That little angle thing there is the exponent key. We call it the caret key. Second caret key. See the pi symbol? Now hit enter. 3.14159262254. And it goes on forever. It's never ending. Okay? All right, so there's pi. There's pi. Practice drawing the pi. Now, what's all this other stuff on here? Any circle, round object you discover, you will discover pi, including your head. Seriously, measure around your head, divide by the diameter, and you're going to get pi. It doesn't matter. Every circle in the world. How about this bell I keep dinging, right? Measure it, calculate it, and you get it. It's the universal constant in math. All right. Before we move on, look at this circle and notice it's been divided up into a bunch of pieces. What is all these symbols, Mr. Miller? Do you know how many degrees are in a circle? Okay. Now, as a class discussion, pause this video and have a discussion. How many degrees in a circle, right? For you skateboarders, come on, help us out. I get a Brody, right? A 360, okay? So pause the video. You guys have a class discussion. The idea is we want to mark this up. Okay, so I'm going to grab green here, and we got 0 degrees. If we go halfway, you do a what on your car, on your skateboard? What's that called? A 180. Okay? And then you go all the way around. That's called a 360. So everybody mark all that. So let's do a couple quick, easy math problems here. What's half of 180? What goes up at the top? 90 degrees. Okay? 90 degrees. Now if I go 0, 90, 180, does anybody know off the top of their head? What's straight down? A 270, right? You guys watch the X Games, right? What's a 1540? Huh? How many times around did Shaun White go? Okay? Come on, you skateboarders. Right? What's that famous skateboarder's name? Come on, you longboarders. Alright. Now, we got the 0, the 90, the 180, the 270, the 360. In class, I'm hoping you guys discuss what this might be. It turns out we cut the 90 in half to a 45. Halfway between 90 and 180 turns out to be 135. 180 and 270 is a 225. 270 and 360, this turns out to be 305. And then they filled the rest by counting by 30s. 30 degree, 60 degree, 90 degree, which is already there, 120 degree, 150 degree, 180 degrees, 210 degrees, 240 degrees, 270 degrees, 300 degrees, 330 degrees, and then we're back home at 360 degrees. Okay? Now, over the next few years, 2 years to be specific, we're going to end up filling out all of these little markings. But for today, we want to make sure that we know about pi and that the circle is divided up into angle measures, and that unit is called the degree. Okay? Okay, now we want to have a little bit of fun. I want you to mark your triangle. Okay? Now that handout that we mailed home, okay, the mailer, we're just now finishing Module 3, Topic 1, and this entire second page is called Trigonometry. But before we do the trigonometry part, we want to study a little bit about special right triangles. Okay? And there's 2 special right triangles. The easy one, the 45, 45, 90, and those of you, if you remember back when we did the area of a triangle, you guys remember area of a triangle? Okay, remember we had this square here, and the area of a box is length times width, but we wanted the area of a triangle, so we cut it in half. Well, half of a box is a 45, 45, 90. 45, 45, 90. Well, you just saw on the other side, on that previous page, that I could mark all those 45-degree triangles. So let's just grab a highlighter here. 45, 45, 90, right? 45, 45, 90. 45, 45, 90. 45, 45, 90. A bow tie. Okay, now let's do another thing. Let's do the 30, 60, 90. Okay, so now we drop it straight down. We go across and we go straight up. Down and up. Over and down. What's that? Can you see the 60 degree? Drop it straight down. 60 degree. 60 degree. 60 degree. So take some time and study that, because if you notice on the previous page, I said we counted by 30s. Can you see now that we can count by 60, 120, 180, 210? Okay, now in class we're going to pause, we're going to take time, we're going to do all this. For this video we're already at 15 minutes. You can tell we're only in class for what, 42 minutes? What we wanted to finish the day with was you knowing that over the next 2 years you're going to mark this circle up and you're going to learn so many cool things, because the circle is what makes the world go round. See, we could actually measure the circle that I'm in right here and divide by diameter and get pi. Our last activity today is to make sure that everybody can use their calculator and everybody gets used to squared and square root. See squared and square root? Remember, when they're side by side or on top of each other, they're the opposites, right? Plus to minus, multiply to divide, square, square root. So, to finish class, this is what we did. We wanted to calculate x here. Well, to calculate x, remember the Pythagorean Theorem. A squared plus b squared equals c squared. So I'm just going to whip this up in this video. 8 squared plus 6 squared equals x squared. Okay, 8 times 8. 8 times 8. 64. 6 times 6 is 36 equals x squared. Remember, we got to know our vocabulary. This thing's called the hypotenuse. Hypotenuse. Look at the back of the classroom. You see that giant green triangle Mr. Miller made you? All right, the hypotenuse. Across from the 90. 100 equals x squared. Change colors here. Take the square root of both sides. The key, if you walk away with anything today, pi is circumference divided by diameter. If you walk away with another nugget of knowledge, the opposite of squared is square root. To undo a squared, you take the square root. Remember the opposites, the inverse. So, the square root of 100, come on, come on, come on. Oh, stop it. Second square root of 100. What number times itself is 100? X equals 10. Okay? X equals 10. I'm going to end the video there. Your job is to calculate x. 5 squared plus 12 squared equals x squared. You calculate what is the hypotenuse of this triangle. Hey everybody, have a great Pi Day. Thanks for participating. And see you on the Wednesday, Thursday, where we continue to learn more about this square root button. It's called the radical. Bye.